post videos of what we do. So if you're absent and it is something that I have like stood up here and talked at you most of the period, I will post that so that you can review on your own at home if you need to, or again, that's great. If you're absent, then you can go through that process, okay? So everybody, let's look the first thing that I'm going to ask for on the quiz. So first off, I want you to be able to show me what the markings on the ruler say. We had done this in one of the first days when we were talking about measuring with the ruler. Now that we know this is a 16th, because if you count the jumps from here to here, and if you count them all out, there are 16 jumps from the beginning to the end. So that's a way to tell the ruler. Some of those rulers over there are 8s. So like the ones like this, they are 8s. So just so you're aware, some of them are not 16ths. 16ths, really, you can see it broken down very far. But some rulers are 8s. I don't know. So anyway, just watch your ruler. Like this one is 16ths, but this one is 8s. Anyway, so here's what I want you to do. I want you initially just to count. So this is 1/16, 2/16, 3/16, 4/16, 5/16, and just write down those initial 16ths for me. So I'll give you all time to do that. I'll do mine. Write in your 16ths for me. Now obviously this inch is blown up so that you can fit all those in there real good. The last one right before you get to 1 should be 15/16, and then 1 is 16/16. So if you could fill those in like I have done there, I'd appreciate that. So that will be the first thing you'll ask to do on the quiz. Now, you won't get full credit unless those fractions are reduced as much as possible, okay? Now, let me tell you how to kind of look and see. If they are the odds, 1, 3, 5, 7, 9, 11, 13, and 15, you can't reduce them. The reason that you can't reduce them is 16 is only divisible by 2. You can divide it by 2 again and again and again, quite a few times. So the ones that are odd, 1, 3, 5, 7, 9, and 11, and 13, and 15, those ones are done as soon as you write them down. Now, the ones in between there are even. So I expect to see you reduce those down. Now, how can you do it? Well, like 2 and 16 are both divisible by 2. If they can reduce, you can always start out just dividing them by 2. And so that is 1/8. You can't go any further. That is what it is. But 4/16 is divisible by 4. But if you don't see that right off the bat, feel free to divide by 2 and then divide by 2 again. That works. There's nothing wrong with that. And that's 1/4. 6 is only divisible by 2, and 16 is 2. They only have a common factor of 2. So that's 3/8. Technically, what's happening, this is 1/8, 2/8, 3/8 is technically what's happening. Now, 8/16, if you just notice where it's located, you can kind of tell very clearly that 8/16 is at the 1/2 mark. So if you know it's 1/2, fine. If you make 8/16 4/8, then do it again and get 2/4, and do it again and get 1/2. Nothing wrong with that, but keep going until you can't go any further as reducing it. So technically I want 1/2, but if you show me any of the ones in the middle, go for it. Nothing wrong with that. 10/16 is a nice one. 10/16 right here. Both of those are only divisible by 2, so you just cut them in half. So that's 5/8. 12/16 can divide by 4. It kind of goes, it can divide by 2, then 4, then 8. 2, 4, 8, in a kind of weird way it does that. So 12/16, if you divide both top and bottom by 4, you get 3/4. But if you think about fourths, 1/4, 2/4, 3/4, 4/4. I mean, it is breaking down in fourths. So, I mean, some of this you can use logic and how it looks is helpful. 14 and 16 are both divisible by 2. So that's 7/8. And then 16/16 is 1. I mean, you don't even necessarily have to write the 16/16. I wouldn't take and mark anything wrong if you didn't mark that one. Now, on quizzes or tests, I usually will give you some opportunity to get a little bonus here and there for those of you that have thought about these things above and beyond. So the bonus that you can get here is if you label the top with your decimal equivalents. So, we start out at 0. The decimal equivalent of 1/16 you can put into the red calculators, the ABC button. You hit 1, then you hit 16, and then you have to hit the FD button, which is that fraction to decimal. Or the easier way, just do top divided by bottom. So any fraction can be turned into a decimal. Just do top divided by bottom. So 1 divided by 16 is going to get it for you. That decimal value, to get yourself a little bit of bonus, is 0.0625. And then keep going down the list. 1/8 is 1 divided by 8, 0.125. 3/16 is 3 divided by 16, 0.1875. Now it's going to keep going up by a 16th each time, so each time it's going to go up by 0.0625. So if you fill in the top, which I'm not going to waste time doing, but if you want to, you can do that. If you fill in the top with the decimal equivalents, you're right if you get to here. This one's 0.5, this one's 0.75, and of course, there you should land at 1. So anyway, if you do the decimals across the top, I'll give you some bonus on the quiz. Do we have any questions about the markings on the ruler that I want you to show me? Okay, so there's that. Now you're going to need your ruler. Make sure you get a ruler to the nearest 16th. Tomorrow, during the quiz tomorrow, I'll try to narrow down the rulers that go to the nearest 16th, so that I can look. Now, check your ruler. Do you have 8s or do you have 16s? And I'll set the 16th ones tomorrow out. So if you need to grab a 16th ruler, feel free to come on up and grab one. So those ones laying out there are 16. So if you need to grab yourself a 16th ruler, go for it. It does need metrics on it. So even if you combine 2 rulers, because this one has metrics on it, the little protractor-y ones do too. Okay. So now at this time, on the quiz tomorrow, there'll be 2 lines that you need to measure to the nearest 16th and the nearest 10th of an inch. Yeah. I don't want you to. So what we're going to do, we're going to actually physically measure these lines. Give me a second to get. Okay, now I can't do it up on the board, so I'll tell you, where you want to do it. But remember, this is just for observation purposes. If you are going to measure something, check out where your ruler marks 0. Some of the rulers mark 0 at the very, very end of the ruler. That's common. See how this one has a little black section to show you where 0 starts. Some have a little marking that says 0 on it. So to be accurate, you got to make sure you're putting the end of the line on 0. Okay? So like for me, I'm not going to use this ruler, but I would have to put the 0 mark there before I actually measured. So at this time, you try it, and then I'll tell you what I'm going to get. Let's measure just these lines with the inches. part of our ruler. Write down what you think you're going to get. I'll do mine too. Because I need to do it on paper. Make sure you're using the 0 mark. Okay, so let me tell you what I got, and then you can compare it with what you got. When I set this ruler on the 0 marking, after the 2, I counted 7 more spaces, okay? So I got 2 7/16. Now, if you thought it was 6/16, let's reduce it down to 3/8. Good. If you're like 1 over or 1 under, I'm not going to count it wrong, okay? Because, again, this is not a precise measurement. You know, we're doing the best we can. So as long as you're close to the 2 7/16, so again, if you did 6/16 or 8/16, which can reduce, I'm going to give it to you, okay? The second one, B, was a much shorter line. When you do it on your paper, I counted 14 marks from 0, 14 jumps from 0. 14 over 16 reduces down to 7/8. Now, if you got 13, I'm going to give it to you. If you got 15, I'm going to give it to you. So I'm going to give you a wiggle room of a 16th. So you can be 1 above or 1 below, and I'm going to give it to you. Do you guys agree with my measurement? Was that seem to be about right? Okay, thank you. Now let's do centimeters. So for me, I have to flip my ruler over. Centimeters are great because each little jump you count after, like if you're a 2, each little jump you count would be 2.1, 2.2, 2.3. So it's great. It automatically does to the nearest tenth. Go ahead and measure now to the nearest tenth. Make sure you're putting on the 0 mark again. We're going to do 1/10 of a centimeter. And I'm going to give you a wiggle room. You can be 1 above me or 1 below me, and you'll all still give it to you, okay? Just so you know, I expect that you may have something just a little bit off of me, and we'll be fine, okay? So check what you got compared to what I got. For the top one, I got 6.2. So I'm going to give it to you if you put 6.1 or 6.2 or 6.3. So if you're a little bit 1 higher or 1 lower, good to go. You got it right. Same thing for the bottom one. I got 2.2. But if you get 2.1, 2.2, or 2.3, I'm going to give it to you. Okay? So just try to be as accurate as possible. I know, again, I wear glasses. Little measurements are hard for me sometimes. I know that everybody, so I will give you a little bit of leeway, okay? Any questions on how we did the measurements with the ruler? So that's really the only ruler one you're going to do tomorrow. One like that. There'll be 2 lines on the page. You're going to measure them to the nearest 16th and to the nearest centimeter. Okay, so now let's talk about some word problems. So if you could, let's take a look at these ones. Okay, it says Mark needs to buy gravel for a driveway. The rectangular driveway is 15 feet wide and 12 feet long. So my suggestion to you is they mentioned the shape of it. So let's draw a shape. And it doesn't have to be, as you can tell, it's not to scale. It's not a beautiful picture or anything. It's just a place for us to put our information down. Now, it says it's 15 feet wide, so I'm going to make the longer one 15 feet. Again, it's not to scale. And then I'm going to make the 12-foot the long part. Okay. So just label it. It doesn't have to be perfect. You can tell mine's not perfect. But what it does is it gives us information. Okay. So right above here, do you see where it says formulas to know? Okay. For us to do this problem, we need to find, or use, the perimeter of a rectangle, which is 2 times the length plus 2 times the width. So that is one formula to make sure that you memorize tonight if you didn't have it. If you forget a perimeter formula for many things that have straight edges, you just add up all of the sides. So if worst comes to worst, for like this driveway, we could do 15 plus 12 plus 15 plus 12. The way that the formula makes a shortcut is we can have 2 15s and 2 12s. So that's where it kind of makes a little shortcut. But perimeter is just the distance if you had to take a tape measure and measure on the outer edges. Please know the area formula is length times width. I'll just put a little dot there for multiplication. So those are some formulas that you will need to know for the quiz tomorrow. So let's go ahead now, and now that we have those formulas, let's do part A. Okay. So for part A, the perimeter, so we have 2 different ways we can do it. We can just add up the sides. So 15 plus 12 plus 15 plus 12 is a totally okay to do this perimeter. The shortcut way is to use the formula. We have 2 15s, we have 2 12s. That's the easier way as far as mathematically. 2 15s is 30, 2 12s is 24. You get 54 feet no matter if you use the formula or if you just add up the measurements around the thing. So it doesn't matter to me. I always figure there's many ways to do a math problem. And so, hey, do it how you need to do it. Now the area, we're kind of stuck. The area, remember, is length times width. So that's going to be 12 times 15, or 15 times 12, it doesn't matter. They're pretty much interchangeable for this. 12 times 15. So you can put that in your calculator if you want, is 180. But here's where I need to see some things. These are real life applications. You'll notice for perimeter, I put the FT for feet. What do I have to write the units down for area? The square. Now, if you are a person that writes out the word square feet, go for it. If you put that SQFT, go for it. I usually will go the shortest way possible, so I'm going to put FT with the little square on it, okay? Any questions about the rectangle one? Okay. Part B. Part B talks about a square. So let's go back up to our formulas. And I will make a very feeble attempt to draw a square. Now, a square is just a fancy, perfect, lovely rectangle. So you don't really need to know extra formulas, technically. But we know these sides match. We know these sides match. So often they'll call it a S for sides that match. So this time the perimeter would be 4 of those sides added together. So 4 times the sides will work. Or you can do side plus side plus side plus side. That works too. And then the area, the length and the width would be side times side. You can write it like that. Or you can do sides squared. So technically it is the formula for a rectangle. But it's just perfect and lovely because the sides match. Okay, so you don't really need to know an extra formula, but it's okay. Okay, so now let's go back to B here. It says Mrs. Hott walks a square path where each side is 3,000 feet. So let's go ahead and draw that. So let's say I'm walking around somewhere where the path is square. So this is 3,000 feet, and this is 3,000 feet. Now, if I'm walking around the path, and I'm walking around it, just one little lap around this path, is that an area or is that a perimeter? It's a perimeter, right? I am going around the outer edge of it. I could calculate a length that I have walked. So the perimeter of this, you can do it a few different ways. But I have 4 sides that are each 3,000 feet. So the total that I walked was 12,000 feet. Okay, so I walked 12,000 feet. Now, Mr. Haught walks a different path. He walks a circular path that is 2 miles long. Now, here's the information. Who walked longer? Did Mr. Haught or Mrs. Haught walk a longer path? Now, I gave you a little hint here. If Mr. Haught walked 1 mile, it would be 5,280 feet. But he walked 2 miles. How could we calculate how long of a path he took, Tommy?
5,280 times 2.
Okay, so let's do 5,280 times 2 to see how long of a path Mr. Haught took. So Mr. Haught went 10,560 feet. So now it's a comparison because we have kind of like things to compare. I walked 12,000 feet. He walked 10,560 feet. Who walked the longer path? I did. So you can just put Mrs. Haught, or Mrs. H is probably good. Okay. So this one would be 12,000. Okay. So I'm going to ask you questions like that. And then I also wanted to, continue some of the thoughts we were talking about yesterday. Any questions on the front page before we flip over? Okay, flip your paper over, please. Let's take a look at number 4C. It says a room is 30 by 24 feet. Find the following measurements. We want the perimeter, we want the area. Let's do that first. Now remember, I told you we're assuming a room. We're going to assume it's just a rectangle. So let's draw a rectangle. And let's label it. So I'm going to put 30 on the longer and 24 on the smaller. Okay. Now, if you know your formulas, then we're good to go. Because the perimeter is just going to be 2 times the 30 plus 2 times the 24. Or you're allowed to do 30 plus 24 plus 30 plus 24. Think of if you were actually walking it. So that's going to be 60 plus 48, or 108 feet is our perimeter. So if we actually needed to put a border around the room, that would be perimeter. If we needed to, that's probably the best one I got there. Okay, now let's talk about area. The area of a rectangle is length times width. So just do in your calculators 30 times 24. And you're going to get 720 square feet. Please, I will take off some credit if you do not label your units. Okay, so make sure you're labeling everything. Okay, now let's take a look at part 3. It says square foot tiles are 88 cents each. How many tiles would you need to cover the floor? So we just found that the perimeter was 108 and the feet, and the area was 720 square feet. To cover the floor with tiles, which one of those measurements are important to us? The square feet, right? Because we're covering the floor with squares. How many squares will we need if each square is 1 square foot? We need the 720, right? Does that make sense? We measured the calculation was 720 square feet. If each tile was 1 square feet, we need 720 of them. How could we find the total cost of the tiles? We're going to wait and see if any. Multiply. So what are we going to multiply? Aubrey, tell us, how do we do it? Exactly. So 720 times 88 cents. Make sure you put in that 0.88 or 0.88 is going to work too. We're rounding to the nearest penny. I think, though, it comes out pretty nice. Let's see. Oh, so here's what the calculator reads. 633.6. That's not how we write money. What's a better way to write that? What's a better way to write that? Dan, how would we write 633.6 in money? Okay, if the answer said round to the nearest dollar, yes. But if we wanted to keep the cents, how could we write it? Go ahead, you can share. You're going to move the decimal place over. Since I kept the decimal point 88 bits in the beginning, we can just keep it. We just have to add a little something. So you're on the right track. Yes?
Add a 0.
Add a 0. So remember, money, you always have to have 2 decimal places showing. So if you started out using this dollars 0.88 cents, this will come out nice. If it doesn't show 2 decimals, show 2 decimals. Let's put our dollar symbol. So it is $633.60. Okay? We good? Okay, next. On the test, I'm going to give you just some shapes, and I'm going to ask you for area and perimeter. Okay? So for this one, to find the area, what kind of shape is it? Rectangle again, and so our area would be 8 times 3, or 24. What kind of units do we need on the area? Centimeters, but we need one extra thing. Squared. Okay, so that's square centimeters. Perimeter, we need 2 8s plus 2 3s. Or again, you can do 8 plus 3 plus 8 plus 3. It works. That's 16 plus 6, or 22. What kind of units do we need there? Just plain old centimeters, right? Because it's a length. Everybody good with that? Okay, so I will just give you a shape. We haven't had any with a triangle yet. So let's go back up to our formula page. So flip your paper over, and I'll scroll up here. And then let's, yeah, okay. So I'm going to draw a triangle. I'm going to draw 2 different triangles. So and I'm sorry again, my triangles will. If you have what's called a right triangle, where 2 of the sides are making an L, like if you think in geometry class, the kinds of triangles you use the Pythagorean theorem on. This would be the height, and this would be the base, and the area is 1/2 base times height. Okay, so that's one way it can look, and that's okay. So that's one way it can look. But if it's not a right one, and I'm sorry, it probably is a right one, but if it's not a right one, and you have to find the height sometimes, like if you were actually measuring how tall it would be if you could stand it up. You still use 1/2 base times height, but the height sometimes can be in a funky location. And it would have to be marked, and it would be marked with that little 90-degree angle mark. Okay, you still use 1/2 base times height. If you wanted to do perimeter of this, you would need to know the length of all 3 sides, and you would just add them up. Side 1 plus side 2 plus side 3. So we can write that. Perimeter would be side 1 plus side 2 plus side 3. I didn't have them marked here, but you just add up the 3 sides. Okay, so that's another formula we're going to need. 1/2 base times height. So if we go to this and it says what is the area of our triangle, let's write down that formula. 1/2 base times height. Now multiplication is commutative, so sometimes if I'm doing it in my head, I'll do the base times the height and then cut it in half. So that's one way to do it. But you can just go from left to right. It doesn't matter. Multiplication, you kind of have a little bit of wiggle room of how you can do it. This would be our height. See how it's marked with that little, it's called an altitude. If you took geometry, that would be a word that they used in geometry class. And this would be our base. Let's take those information, let's shove them into the formula. So the area is 1/2 base times height. So 1/2 of 10 times 4. What is half of 10? 5. So it's very easy to take half of that because it's just an even number. So it really just becomes 5 times 4, or 20. But there's units on the page. These are inches. So area units. Square inches. So you can put the SQIN, or you can put the square inches like that. I tend to do that. So our area is 20 square inches. Okay? So this is what your quiz looks like. So please, whatever you need to study tonight, you can take this paper home. But at this time, if you could, please, I need you to go into Google Classroom, find where it says 1-1A quiz review, and take a picture of what you just did to get credit for it.